Welcome all of you to another video of Animats. Now, as I told you in my previous video that I shall be doing speed distance type of sums today. So, in this video we shall be taking the different types of those sums where there are two cars maybe moving in one direction or two vehicles moving in the same direction. So, we are going to take up those type of sums. Yeah, we are also going to take up sums where you will see that a train crossing a lamp post, crossing a platform, or crossing a bridge, crossing another train coming from a different direction, from the opposite direction. So all these sums we are going to take up in this video. So let's start. Okay, so this is the first question. A train 180 meter long running at a speed of 90 kilometers per hour. How long will it take to pass a railway signal? Okay, so here we have railway signal is, remember, is like a lamp post. Okay, now the train is coming from this end. Okay, now how long will it take to pass a railway signal and the train is 180 meters long? When they say the train is 180 meters long, means the engine has to pull the last coach out of the lamppost. Okay, it has to cross the lamppost completely, including the last coach. So how much distance will the engine run in order to cross the lamppost completely? That distance is the length of the train itself. Okay, speed is 90 into 5 by 18. Why 5 by 18? Here I saw meters, I have to get it in meters per second. Okay, so I have it 90 into 5 by 18. This is 5 clear, 25 meters per second. I have distance, I have speed. Now I'll get time. Time is distance by speed, which is 180 by 25. So 180 by 25. 5 5s are 5, 3s are 15, and 5 6 are. So 36 by 5, which is 7 1/5 of a second, that is 7.2 seconds. Okay, how do I get this 0.2? Okay, let me work out that also. 1/5 15.02. Okay, so this is how 1/5 got converted to, so a fraction got converted to a decimal. So it is better to write like this, 7.2 seconds. So this was one train question where it crossed a telegraph pole. It crossed a railway signal. Same thing can be asked for a telegraph pole. Same thing can be asked for a lamp post. It can be asked even for a man standing. Okay. Now here in these questions, remember one thing, we neglect the thickness of the pole, the signal, the post, whatever, the thickness of it is neglected. We will do some other sums where the thickness is included. Okay. Now here is another question. A train whose length is 150 meters passes a telegraph pole again in 10 seconds. Find the speed in kilometers per hour. So it is just a repeat of the previous question. So here again distance according to my previous sum is this. Time is 10 seconds. Let me find speed, which is distance by time, which is 15 meters per second. But then that is not what we wanted. So speed in kilometers per hour is 18 by 5. Okay, so that is 3, that is 54 kph. Okay, so this is it. A train 120 meter long passes a railway platform 160 meters long in 14 seconds. How long will it take to pass another platform which is 100 meters long? Okay, so first we'll concentrate only on the first part of the question. Now here is the train which is 120 meters long, and here starts the platform which is 160 meters long. Yeah, so the engine of the train which is here has to cross the platform, but then if it crosses, the train will be partly inside the platform. So to completely cross the platform, it has to pull the last coach out of this end. Okay, so the train has to go here, that is 120 meters, full 120 meters has to be here. So how much did the engine actually travel? What distance does it cover? It covered a distance of 160 plus 120. That means length of the platform plus its own length. Okay, so this is the thing you have to understand here. So 160 plus 120 total length it has to cover, and that becomes the distance covered by the train. So that is a 280 meters. So for the sum, distance is equal to speed into time. So we are going to find the speed here, distance by time. Distance is 280, time is 14 they have given. Okay, so 14, 20, straight with 14, 20, this is 20 meters per second. Now we have a second part to the question, which is why meters per second? Because here this was in meters distance and time was in seconds. Now the second part of the question is, how long will it take to pass another platform which is 100 meters long? Okay, so if we have a 100 meters long platform instead of a 160, then the distance is going to be 220, right? 100 plus 120, that is going to be a 220. 220 distance, and now we know the speed is a 20. Therefore, time is 220 by 20. Yes, time is 220 by 20 for the second time. This is, you can name it as T1 and you can name it as T2. Okay, but remember speed is going to be the same. This is D2, this is D1. Okay, so here 11 seconds. Now these sums you have to apply a little bit of your common sense. Say the moment I saw 11 seconds, I checked, okay, the distance was less than the previous one, so the time also should be less. Previously it had taken 14 minutes, now it is taking 11 minutes. So I know, yes, my answer is going correct. Okay, if it is not, if this would have come as 18 at the same speed, you cover 280 in lesser speed and 220 is taking more time, that means there is a problem in your calculation. So you have to check your calculation back. Okay, so it takes 11 seconds to cover 100 meter long platform. Okay, so this is our next question, where we have A and B start from the same place in the same direction and at the same time with speeds. Now if you note the speeds, one of the speeds is 6 kilometers per hour, another one is in meters per second. Okay, so after 5 hours, who will be ahead and by how much? So here we have A starting and B starting at the same place and at the same time. Okay, so A is going at 6 kilometers per hour and the other one is going at 2 meters per second. Okay, so this is the speed of A and B, and remember they are moving in the same direction. So they are moving in the same direction. After 5 hours, who will be ahead and by how much? Now whenever I start with this sum, now why do you all find it tough? Okay, you find it tough because you are not noting the units carefully. After 5 hours they have asked. Had they asked after 5 seconds, I would have converted this to meters per second. But since they have asked after 5 hours, I'll try to take everything in hours only. So this one I'll try to change to 2 meters per second to kilometers per hour. That is 18 by 5. Okay, I've already talked about these changes. So that is 36. So B's speed only I have changed, that is 36 by 5 kph. Now both of them I have in kph. This one and A speed is already given in kph. Distance covered by A in 5 hours, that is, distance is always speed into time, so 6 into 5, which is 30 kilometers. Okay, on the other hand, distance covered by B, okay, in 5 hours, that is equal to 36 by 5 into 5, which is 36 kilometers. Okay, therefore now the Therefore, who is ahead and by how much? Since they had started at the same place at the same time, we can clearly see that B is ahead and he is ahead by 6 kilometers. So, if I subtract 36 minus 30, 6 kilometers, B is ahead by 6 kilometers at the end of 5 hours. Okay. A and B start from the same point at the same speed of 15 kph and 12 kph respectively. Find the distance between A and B after 6 hours if both are moved in the opposite direction. Now here is a different sum, but if you note, there is no problem with the units, they are in the same unit, and here also they have asked in hours. So this is actually simpler than the previous sum. The only difference between this sum and the previous sum is here. Yes, they are moving in opposite directions. Now what do they mean by opposite directions? Means they are here. Okay, A moves this direction, B moves this. Okay, so this is how A and B is moving. Okay, so at the end of 6 hours, distance moved by A in 6 hours, that is speed into time, 15 into 6, 15 into 6, which is 90 kilometers. Okay, distance moved by B in 6 hours is now 12 into 6, 12 speed into time. Okay, that gives me distance, so that is 72 kilometers. So in a period of 6 hours, A has gone 90 kilometers and B has gone 72 kilometers. Okay, so at the end of 6 hours, B is here and A is here. So this distance is the sum of, therefore at the end of 6 hours, distance between them at the end of 6 hours, end of 6 hours is equal to, this time you have to add, and that is this many kilometers. So why I did this sum is because I just wanted to show the difference between moving in the same direction and moving in opposite direction. Okay, so here we have a question which is, two trains are moving in opposite directions at a speed of 60 and 90. Okay, and the length of, so everything is given in kilometers only here, so there's no problem with the units. The length of the train, one of them is 1.1 and the other one is 0.9 kilometers respectively. The time taken by the slower train to cross the faster train in seconds is how much? Okay, now they are moving in opposite directions. Whenever they move in opposite direction, this is how they are moving. Okay, now here I should not say this, I should say they are moving like this. This is coming because they are not starting at the same place. So it would be wrong to say that this is the correct way of moving. So they have started from their respective stations, and here this one is moving in this direction, whereas this is moving at this direction. So one is 60 kph, the other one is 90 kph. Okay, now there's no need to change to meters per second, as I said. Here, whenever you have this kind of questions where both of them, none of them is stationary. Before this we had platform was stationary, it wasn't moving. The man was stationary, he wasn't moving, or the pole is stationary, that wasn't moving. But now we have both of them moving, and still they are asking how much does it take the slower one, that is this one, to cross this. Now if this one wants to cross this when this is also moving, then the condition has to be like this. Yes, this is the 60 kph train and this is the 90 kph train. Okay, now what is the distance that has to be covered? Okay, to completely, this train should completely cross this and the last coach should move here. That is what I have drawn here. What is the time taken to cover like that? The time taken to cover, what is the distance? Let me first talk about the distance. The distance will be 90 plus 60, right, which is, the distance will be the length of the two trains. One of them is 1.1 and the other one is 0.9. So 1.1 kilometers plus 0.9, that gives me 2 kilometers. That is the total distance. Whether this crosses this or this crosses that will have to be covered. Okay, now the time will keep it as t only, and what is the speed? Now this is one very important factor. Whenever both are moving, then we consider the relative speed. Okay, so the sums will be done with the help of relative speed. When both are coming towards one another, then, or in towards one another is also called as opposite directions, because this is finally going this way, this is finally going that way. So this is called opposite directions. In that case, we add up the speeds. So it is 60. Of course, they have to be in the same units, otherwise you can't add. Okay, this is 150 kph. Okay, so now this is the speed that we are going to work with, this is the time, this is the distance that we are going to work out. So time is distance by speed, so it is 2 by 150. Now here 2 by 150 is going to give us in hours, because everything is in hours here, kph. So this answer is also going to come in hours, but we don't want it in hours. Okay, so hours has to be converted to minutes first. So this fraction of 1 hour is how many minutes? So I multiplied with a 60 because I want to convert it to minutes. Now every minute is, now this fraction of is how many seconds? Okay, so we have to further multiply, because every minute is 60 seconds. So we further multiply with 60. Okay, so now our answer is going to come in seconds. So cut this 0. Okay, then 3 2s are 3 5s are. Okay, now we need this 5 and this can go 12. This is a 48 seconds. Okay, so all in one, we didn't have to, in the same calculation only, involve these 60s and get your answer. And don't forget, this 2 by 50 is a fraction of an hour. Okay, if you multiply only till this 60, it becomes fraction of a minute. Okay, it becomes in minutes, not fraction. And if you take another 60 after this, now you are getting your answer in seconds. So if you are multiplying with a 60, you get in minutes. If you are multiplying with another 60 further, minutes are multiplied with 60, then you get it in seconds. Okay, so here is the next sum. Two trains, this time of equal lengths, are running on parallel lines in the same direction, that is 46 and 36. Okay, they are moving like this at 46 and like this at 36 kph. Okay, the faster train passes the slower train in 36. Now note the mismatch in units, this is in seconds. Okay, so the faster passes the slower in, the faster one passes the slower in 36 seconds. What is the length of each train? Okay, so length of each train, let it be equal to x. Okay, then if faster one crosses the slower, then the faster one is also covering a distance of 2x, because it has to pull the last coach out of the engine of the second train, that is this way, this much. So full here to here, and then its own length it has to pull out. So the total length, the total distance covered is equal to 2x. Okay, and time is a 36 seconds, remember. Okay, what is the length? Now what is the speed that we are going to take? Again, it is the relative speed, but this time, since they are moving in the same direction, the speed is going to be subtracted. So 46 minus 36, that is 10 kph. Okay, so whatever calculation we are going to do with 10 kph. Now this 10 kph has to be converted into meters per second, because this is kph, okay, which is 10 into 5 by 18, that is 50 by 18 meters per second. We'll leave it like that. We don't have to get it in we don't have to get it in decimals. Okay, so now what is the time? Time is 36, this is 50 into 18, and distance is 2x. So 2x is equal to 36 into, you see the usefulness of not cancelling. Okay, so if you get a fraction in the middle of the sum, never turn it to the decimal. Then this is 2, that is 100. 2x is 100 what? This was meters, so no confusions. Now it is in meters. Pick up the distance unit from the speed, so this is in meters. Therefore, what is the length of each train? 2x is 100 meters, x is 50 meters. Okay, so length of each train is equal to 50 meters. Okay, so this is it from speed, distance and time. I tried and did every type of question that might be asked, that can be in your textbook at the 7th standard level. Okay, so every sum is a different type. If you note, you will see that every sum is slightly different from the other. So this is it from speed, distance and time. Okay, so next I shall be taking up percentage. So see to it that you are following all the videos sequentially. This will be marked as speed, distance and time part 2, and the link of the first one you will find in the description box. So if you have liked the video, do not forget to like, share and subscribe. Also, if you have further comments, if you have further any difficulties, any questions, you can always ask in the comment section, and I shall definitely get back to you. Okay, that's all. Thanks for today. Bye then.